Good afternoon, year 13s. Hey guys, how's it going? Right, Emma's up on the chat. That's great. It means it's doing something. That's excellent. I'm just waiting for my video on my other screen just to start up, just to know it's all running and it's going okay. And then I can crack on with thermodynamics. Today's lesson, we're going to be doing a recap of energetics from AS, recognizing the fact that thermodynamics, there we go. That thermodynamics is an extension of energetics from AS. And so it's important that we quickly have a bit of a run through of all those kind of, I just want to basically do some bullet points on the steps that you go through for energetics at AS. It's things like being able to do bond enthalpies and hess cycles and all that jazz. And then we're going to drop into thermodynamics for A2. Right. So I'm just going to play around. Ben said, I am here. So I've got myself a new webcam. Way, look at that. Webcamming it up. And this is, of course, the webcam here is separate from the one that I can write on. So it means that I can keep this up so I can, if I need to do a dance, like bond enthalpies. You know, if I need to do that, then I can. You might just be staring at me right on the board most of the time, but, you know, what can you do? Wow, so cool. Wow. Oh, this was a Christmas present, by the way. So, as I said, it will be handy, but the problem is I really wish that I could actually have it a little bit lower. I feel like I have to make a conscious effort to look at the camera. Otherwise, it's just me staring downwards. Anyway, let's move on. So, share screen. No, I'm sharing my screen there. So let's crack on. So the main focus today is doing some revision on energetics from AS. That is my main cause for concern today to focus on. Right, I'm going to switch my tablet to tablet mode. My laptop to tablet mode. Let's go for 13E. That's you guys. That was the very end lesson of acid base. We can swing up my keyboard and we can drop into acid base. Sorry, out of acid base and into thermodynamics. Right, title for today's lesson, folks. A2 thermodynamics. The reason is that energetics is the study of heat energy. It's the study of heat energy. I'll put in brackets enthalpy, followed by its symbol, delta H. So how does this evolve then to thermodynamics? Is anyone else lagging hard? Is it lagging badly? I don't know, Donna. It seemed to have been working okay for the majority of today, but it wouldn't surprise me if there was a problem somewhere. Somebody give me a heads up as to whether or not it's lagging badly. And if I need to, yeah, okay. I don't know whether or not me clearing any of my data is going to really help anything. Probably not. Give me 1 second. Let's see if I can. I'm just going to check something. Say again. Oh, is it? Oh, okay. So it's not that then. Oh, might be Netflix. Right. I had Netflix on the TV. I don't know if it's kind of okay now though. Is that better? I've just turned off my TV, which of course is using Netflix, which of course will eat my bandwidth. No, your voice just broke up for a bit. Any better? Okay, so thermodynamics. Prefer the capital T. Thermodynamics. The study of all energy. So now the main thing here is I say of all energy. I shouldn't really do that. I should actually put the study of heat energy and entropy energy. That's not the right and, is it? It's like that. So the other way around. It's like that. And entropy energy. You can also put as well, really, Gibbs free energy. Gibbs free energy. Now, just to let you know that Gibbs free energy is actually, yeah, I can hear all the drama. Yeah, it's gone now. Okay, cool. I think it's fixed. So just to let you know that Gibbs free energy is a combination of these guys. It's how these guys tie together. But it's the study of all energy. So this is the first time you guys have heard the term entropy. Now, the reason, of course, why we have to do the energetics revisit is because energetics is within thermodynamics. So you guys, I just want, before I go any further, I want to have a look at, because I think everybody in this class, energetics, everyone remembers that energetics was pretty much the hardest topic, in AS chemistry. You guys bombed your test. Very entertaining. And I'm very aware that, you know, I stressed that point when I was teaching you guys this in lesson. I made the emphasis, you know, I was like, guys, this is tough. You need to really work hard on this one. You've got to do more questions. You've got to ask, you got to do more exam questions. You've got to ask me more questions. And of course, you didn't do it. And this is a very common thing to happen. I know that AS energetics is tough. It's the first time you really come across a concept which you picked up at GCSE, and then all of a sudden it grows into this very, very complicated topic with all kinds of oddities and calculations, and it requires you to spend quite a lot of time on it. So doing a bit of a recap on this is worthwhile. I would give a recommendation. So recommendation, nota bene, yeah, review my YouTube channel, review energetics, because I have a full set energetics on my channel, on Toby Duncan channel. Yeah, I've got a complete set there from that I did with my ASs under lockdown. It would be very much worthwhile having a watch of those all the way through the sequence. You can play them at twice speed. Definitely something that's worthwhile having a look at. I know that we haven't done this in a while, and it was one of the toughest topics in AS, so it's worthwhile doing the revision on it. Okay, so the first thing that we came across, number one, we're just going to do some bullet point kind of summary. Let's do a summary list of this. Yeah. So the first thing that we came across was delta H, which you had visited in GCSE in year 11. And I think most people kind of walked into this and kind of felt, oh, I'm trying to raise my chair as high as I can. There we go, it's a bit better. I think people went into this with an idea in their head that they were going to get it, and then when it kind of grows into Hess cycles, everyone gets a bit lost. So delta H is enthalpy change. And then, you know, you describe this as heat energy change of a reaction, and then it quickly develops into definitions at AS. And you get a fair number of them. You get number one, you get delta H bond enthalpy, delta HB. So this is bond enthalpy. And they ask you to define it. The enthalpy change when 1 mole of a covalent bond is broken into its constituent atoms, all in the gaseous state and under standard conditions. Nightmare. Bond enthalpy. Yeah, you get a definition for that guy. And everyone hates learning them. And then you're number two. You get the enthalpy of combustion. Yeah, combustion enthalpy. The heat energy change when 1 mole of a substance is burnt in excess oxygen, forming CO2 and water only, all in their standard states and under standard conditions. Yeah, combustion enthalpy. Combustion enthalpy. I don't really want to write down all these definitions. If you want to pause it and slow it down so you can write it down, you can do. But you got to learn these, unfortunately. You should always have an example in your head of all these, by the way. So this is Cl2 forming 2 Cls, and they must all be gaseous. Can't break a covalent bond unless it is gaseous. 1 mole of a chlorine-chlorine bond being broken into its constituent atoms, all measured in that under standard conditions and in the gaseous state. Nice. Enthalpy of combustion. the heat energy change when 1 mole of a substance or a compound, I say first substance because it's going to be element or a compound, 1 mole of a substance in its standard state being burnt in excess oxygen to form CO2 and water only, all in their standard state. So the CO2 is in gas, the water is liquid, the oxygen is gas, and then balance form CO2 all in their standard states and under standard conditions. Ugh. Yeah, you picked up that one. And then you picked up enthalpy of formation, delta HF. Yeah, this is formation enthalpy. Formation. The heat energy change when 1 mole of a compound is formed from its constituent elements in their standard states under standard conditions. Formation enthalpy. Yeah. So the heat energy change when 1 mole of a compound is formed from its constituent elements in their standard states and under standard conditions. Yeah, I'm just building methane from its elements in their standard states. Standard conditions, by the way, are constant pressure. Key thing. Lots of people think that you can quote a temperature for standard conditions, but not really. It's actually just constant pressure because the temperature is going to change based on the enthalpy. Number 4, enthalpy of neutralization. Delta H neut. The heat energy change when 1 mole of water is formed from an acid and base reaction, all under standard conditions and in the standard, oh no, it's non-standard states. So you don't even need to mention standard states. Yeah, enthalpy of neutralization enthalpy. And it's a weird one, neutralization, because it's about the formation of water, which is a fascinating one because there are some reactions, some, that was weird. And neutralization enthalpy. Yeah, so sodium hydroxide plus HCl goes to H2O and salt and sodium chloride. Yeah, and they're all going to be aqueous. Yeah, that's liquid though, and that's aqueous. So the heat energy change when 1 mole of water is formed from an acid and base reaction under standard conditions. Horrible one. Don't really like that one very much. Feel like it's a bit ugh. And the last one is enthalpy of reaction. This is even more wishy-washy. Enthalpy of reaction. I'll just put react. I'll just put R actually. So this is reaction enthalpy. This is reaction enthalpy. The heat, and this one stands out. EdXL love this one. This one has to be starred. Yeah, because they love asking this one. The heat energy change of a reaction based on a balanced equation, forming reactions, all reactions and products in their standard states and under standard conditions. That's a tricky one, that one. The reason being is they're recognizing that some reactions are difficult to categorize. And it's just easier just to call it a reaction, and they give you a balanced equation, which you apply the enthalpy to. Yeah, but that one's a tricky one, something to bear in mind that does come up fairly frequently. So you pick up these definition lists, and you've got to keep these. Notice that there's a similarity in all of them. Yeah, process I'm running. Yeah, the heat energy change. They prefer you to say I hate using the word enthalpy in the definition of an enthalpy. Like, I hate that. It doesn't make much sense to me. The heat energy change. You can't say the heat change. You can't say the energy change. It must be the heat energy change. The heat energy change when 1 mole of ... Then you have to adapt it to fit your definition. Yeah. Now, most of the time, all reactants and products in standard states, but you have to recognize that sometimes disappears in standard states and under standard conditions. And standard conditions is constant pressure. Standard conditions, which is, by the way, 100 kilopascals. Yeah, you've got to know your STPs. Yeah, STP, train station symbol, stands for STP, standard temperature and pressure. Yeah, and that's 298 Kelvin, but you don't really need the temperature here because the temperature is going to change because it's a heat energy change, and the pressure is 100 kilopascals, and then it stands for standard. So all these things are going to reappear in A2, and I've got to make sure that you guys are on top of these things. So we're now going to pick up a whole load more definitions. I'm so sorry, everybody. And you're gonna hate them. I call it the definition list. Yeah, and there's going to be boatloads of these coming over the next lessons or so. I'm going to do them all in one go. If you're interested, and enthalpy of formation, enthalpy of atomization, enthalpy of dissociation, enthalpy of vaporization, enthalpy of sublimation, bond enthalpy, enthalpy of electron affinity, and enthalpy of electron affinity 2, enthalpy of ionization, enthalpy of lattice formation. All of these are coming. And I'll tell you guys which one I'm commonly given, but learning that routine is really handy. Yeah, the heat energy change when 1 mole off and give an equation basically gets you most of the marks, to be fair, as long as you give the right state symbols. It's actually really good. And you guys have to learn those. It sucks, I know, but it's part of it. Right, now that we've done, those were all the definitions, by the way, that you had at AS. That was it. 5, you're now going to get another 10 on top of that. Now what I want to do is, I now need to talk about your different reactions that you were doing in terms of Hess cycles. So we need to do Hess cycles. So we learned Hess cycles are a proverbial nightmare. I am not a fan of Hess cycles. You have to learn to use them, but I prefer to avoid them where possible. Yeah. So the rules here is be able to use, because they're going to force you into it. Yeah. Will be provided. And you've got to be able to do that. But what they're then going to do is they're then going to make you construct simple Hess cycles. Yeah, not complicated ones, just simple cycles, usually using combustion or formation data. Yeah, I'll just put combustion stroke formation data. And then they give you mixed data. And at this point, you've got to be mixed data is the important one, mixed data, because you now avoid the Hess cycle altogether and you're going to do equations. I'll give some examples of these in a second if you wish. Yeah, use equations. And that's hard. Like, you've got to get really good at this, guys. And it is important that you do. And you realize how much practice this took when we did the topic originally. And then once we've talked about Hess cycles, what we then went into was calorimetry. Yeah, calorimetry. So calorimetry was Q equals MC delta T, followed by divide by 1,000, followed by delta H equals Q over N. So we learn that this is the practical method. Yeah, this is a practical method for measuring heat change. Method for measuring heat change. Heat change, heat energy change. Should never do that. Pet peeve, shouldn't do it. Yeah, this was like internal and external calorimetry. Yeah, all that jazz. So this was AS, and AS is tough. As I said, most challenging AS topic, except for Group 7. I despise Group 7. Everyone does really badly in Group 7. But energetics is hard. Bonding's hard too. But energetics, it just seems to just like, students don't like it, and I get it. I do. It requires more practice than most, and it requires you to be a bit more fluid, a bit more dynamic in the way that you look at your chemistry. Lots of students, when they're at this age, tend to see chemistry as, oh, if I practice it over and over and over, I'll be able to do it. Well, yeah, there's only so far that can take you. It can get you the level 8 and 9 at GCSE, but if you're learning by rote at A level, you're going to be scoring an E or a D, because you've got to be a bit more fluid. And this topic requires you to be more fluid than most. Being able to look at a question, understand what that question is doing, and be able to make those adaptations to the method by which you might be trying to solve that problem. You know, you've got to be quite fluid in this, and it's tough. You've got to be well versed, and you've got to have come to see me. You've got to spend some time asking me those questions. I don't understand why you did this. I don't understand that when I ran this, it didn't come out the way it was meant to. Where did I go wrong? Trying to troubleshoot these is actually super beneficial. For me, it's actually the most fun part of energetics, is troubleshooting what you guys are doing. to be able to solve those issues. But yeah, anyway. So that is kind of a brief summary of what we did in energetics. It kind of brings it to a close at that point. We talked about Hess cycles, and then we talked about calorimetry. I could go on about things like not being able to measure certain things directly, but I don't really think I need to. So what we now need to do is we now need to look at the study of energetics. So my learning objectives, which I posted on the YouTube video. So this is thermodynamics. This is thermodynamics lesson 1. And I think my learning objectives were probably something like recall AS. Yeah. And really, I just wanted to bring this because I wanted to remind you that this topic is hard, and I want you to take a bit of time to go back and revisit. I've got a complete set of lessons on YouTube now, and it's worthwhile running through them. Watch them at double speed. It'll be very worthwhile just to bring that back, because it's been 6 months since you looked at this, and I'd really think that would be good value for you guys. I think you'd make a mistake if you didn't watch them. So recall AS. The next thing is now to bring in Born-Haber cycles. I think that was my learn. Just want to check my learning objectives. I don't even know if I can actually do that. Edit. Yeah, Hess's law and covalent and Born-Haber ionic. Okay. So this is to understand Hess from a covalent perspective. So we've been drawing Hess cycles for a while now. We've been given, so let's have a look at an AS question. I think that's very reasonable. Let's do that. You guys, good Hess law questions. Oh, nice. Hello. Let's go for that sheet. Somebody asked me for it, so I sent it to them. Right. Oh, it's going to make me want to build. Oh, I hate cycles. I hate cycles. Okay. I'll do this one. I'll steal this one. Okay. Oh, I hate this so much. I don't even know if I could actually do this. It's been so. I avoid cycles as best as possible. And I always kind of feel like, because I spend so much time trying to avoid cycles because I can do it better without them, I just feel like when someone puts me on the spot and goes, can you do this via a cycle? I always make a mess of it. Probably could. It'd be interesting for me to try. But what I want to point out is this is a very simple Hess. It's not a simple Hess question. It's a complicated Hess question, because the data we've been provided is unlabeled. Unlabeled data. Now, what that means is it's otherwise known as mixed data. Sometimes you can get, that's unlabeled, and mixed data is when they tell you one's combustion, one's formation, and you don't know which one's which. So unlabeled is the same as mixed. So we're going to be using equations to solve this issue. But what I want to point out, and something that nobody ever actually asks in class, because they never really get, it's not the fact that they don't spot it, it's the fact that as the teacher, we deliberately guide you away from this question. It's the recognition that Hess cycles are being used in covalent compounds. What we're not looking at here is we're not looking at anything ionic. The reason being is ionics need a much more complicated process when you're building them. With covalents, it's very straightforward. So Hess is covalent. So let's do Hess cycles, and we can say based on covalent bonding. Based on covalent bonding. So we're getting given values of the creation of this compound, or the breaking of that compound, or the making and breaking of these bonds, and they're all based in the covalent world. We're just making and breaking covalent bonds. And you can get that all from the bond data that's provided to you in your test. You know, you get that data sheet with all the values of all the bonds. But when we get to then, of course, when we get to A2 now, we now need to start looking at this. I don't know why my keyboard keeps appearing, by the way. I haven't got a clue. It just look at that. It just keeps popping up. My laptop is doing something funny, and I don't know what it is. I don't know what I've gone and done, but I've done something. And if it keeps appearing, I'm going to get really annoyed. So based on covalent bonding. Okay, so the next thing I want to do is let's actually have a go at this question. I think that's very reasonable. I think people would be annoyed if I didn't have a go at this. So the question here states that I want to know the enthalpy of reaction. Now, this reaction, by the way, is a dehydration. So, or a condensation. No, it's not a condensation reaction. This is the difference. This is a dehydration because we're removing water. Yeah, so if people are now wondering what the difference is between a condensation and a dehydration, the difference is that a condensation is two things come together to release water, whereas this one is simply we're removing water from a singular structure. That's the difference. So we want to create that equation there in yellow from this data. And I taught you guys how to do this at AS. So the first thing I need is I need 2-methyl-propan-1-ol. So find that in my table and it's there. Now the problem is it's on the wrong side. I need to create this equation, and this equation here has 2-methyl-propan-1-ol on the right-hand side, and I need it on the left-hand side. So I'm going to reverse that equation. So C4H10O liquid goes to 4 carbons plus 5 hydrogens plus half O2. And that gives me a value, go away, that gives me a value of plus 335. So the reason why I have that value and why the sign has changed is because I've reversed it. And we know from GCSE equilibrium, when you reverse a reaction, it's the exact opposite in terms of enthalpy change value. But even though it's unlabeled, could you do a Hess cycle being the enthalpy of formations? Just it looks like it. Ria, if you want to try and do that via a Hess cycle, please go ahead. I am senseless. No. Ria, I get it. And in fact, like I said, someone can bully me into trying to do this via a Hess. Oh, you're going to make me do it, aren't you? I hate you. I will attempt to do this via a Hess cycle in a minute. I hate you guys. Anyway, I'm going to do it via equations because I know I'm going to get the right answer. And then I'll try it via the Hess cycle. I hate Hess cycles. Anyway, I've now got him. He's there. Plus, by the way, I haven't had to multiply this at all because I only needed one of them. There's one in that equation and one there, so no multiplication needed. Right. Now that I've got him, what I now need is that guy. Oh, he's there. I like it. He's even on the correct side. C4H8. What am I making him from? 4 carbon solids plus 4 hydrogen gases. Amazing. So I've now got him. Tick. Take you. Got him as well. Now check this out. The carbons just cancelled out because they're on the opposite sides. 4 of my hydrogens have just disappeared. I've still got oxygen to get rid of though. Oh, now, so by the way, this equation, I only needed one of them because it's got one there and I have one here. So I'm going to just put that value in as minus 17 times 1 because that's how many I needed. The next equation, of course, is I need to get rid of half an oxygen and 1 more hydrogen. And I need water. So I need water. Here's the equation with water in it. It's even on the correct side, which is quite nice. I'll put that underneath where it should be. And then I'm going to make that from hydrogen gas and half O2. And what you realize is they vanish. So they wouldn't appear. They wouldn't appear in the Hess cycle at all. The only thing that's going to appear in the Hess cycle are the ones that don't cancel. So the final reaction is exactly what I had before. Put these all together. C4H10O goes to C4H8 and 1 water. And also that was on the correct side. So I can now just go minus 242 times by 1 because I only needed one of them. And then all I do is add these together. By the way, and just to show you that process, by the way, just to show you that the equation that I have formed here is exactly the same as the equation I formed up there, which is quite nice. But just now to show you how I add them together, you put them all into brackets and then just add in the gaps. So plus brackets plus 335 and then plus brackets minus 17 brackets plus, just add them all together and put them in brackets and let the calculator do. Dat will absolutely be having an absolute mare right now going, Mr. Duncan can't flip his signs when you got pluses and pluses. I can, Dat. I'm just much more reliable when I don't do it myself and I let the calculator do it. It's just better to do so. I'd like to see Dat post on the chat. Dat, would you agree with me that it is more reliable to let the calculator do it? Say no to that, Dat. I dare you. Anyway, 76 plus 76, and there's my answer. Winner, kilojoules per mole. Kilojoules per mole. It's reasonable that I would check my answer. You know, this was a tough Hess question. There'll be people here going, yeah, I had no idea how to do that. You know, it's been a while. So that was question number 1, and the answer is plus 76. Booyaka shaman. Yes, under exam. Thanks, Dad. That's amazing. Just put a clause in it. I love it. It's like, and under exam conditions. Sure. Actually, Dad, I do disagree with you there, by the way. It's more reliable whether or not you're in exam conditions or not. Like, it just is. Yeah? Wow, T. Wow. I don't quite understand what the wow's about. Anyway. So, oh no. I'm so sorry. I'm going to ruin this now. This is Ria's fault. I try to avoid Hess cycles as much as possible, everybody. This is something I don't usually do very often. I know what the answer is now because I've already done it, but I'm going to attempt Ria's horrible, mean. Oh, I said to you that people make me do this. I'm not very well practiced. I'll give it a shout. I'm going to make a mess of it, but, you know, fun and games and all that. Chemistry is all about taking chances. It's so not about taking chances at all. By the way, I have no idea why my laptop's going so slow. No idea. Laggy. Right, so we're going to try and do this via a Hess cycle. Now, can I just point out, Hess cycles are mean just because you've kind of got to figure out which. The way I tend to tackle Hess cycles is I tend to look for the most complicated equation that has more in it than anything else. And things that have more in it than anything else is this one here. And I'm tempted to put that one as the top reaction. Really tempted. Okay, now let's just try following the normal routine. C4H10O goes to C4H8 plus water. Okay. So the first thing is I need to build that guy. I'm going to build that guy from 4 carbons. 4 carbons plus 5 H2s plus a half O2. Yeah, I can make that. Oh, it's just elements. Okay, fine. Yeah, can be done. It all balances as well. Huh, that's entertaining. So in this case, it's probably easier to actually do a cycle, but it's really not. Like, it's just not a good idea. If the table's unlabeled, if the data's unlabeled, please don't use this method. I know that it happens to have just fallen into place. These elements are needed to make that. It's because it's all formation data from elements. Yeah, but when it's truly mixed data, it's an absolute fiasco. I don't really want to fill in the rest of these now, but 1, 3, 5, minus 17, and then minus 2, 4, 2. Those all numbers all add up. So this way equals this way. So this arrow is going against me because I'm moving in this direction. So my final equation is, I'm going to get rid of these circles, just make it easier for myself. So minus, because it's against me. That means that literally means against, brackets, minus 335, close brackets. This one's with me because I'm moving in this direction on this side. So that the plus now means with me, minus 17, brackets, 17 brackets, and that one's plus again, minus 242. It gives me the same answer of 76. I get it. You need the plus, by the way. Forget the plus, you forget your mark. So, okay, not a great example. Let's find another one. Let's find one of truly mixed data. One just to really upset people. Yeah, that'll probably do it. Yeah, that's a nightmare. That's a mess. All kinds of horrible data. You got it at multiple levels. Tempted to have a go at that one, just for fun. Yeah, for fun. New. Oh, I'm gonna make a mess of this. I'll make a mess of this one. That's okay. It's all about fun. It's all about the fun in it. So I'm trying to build this reaction. Blue. I'm trying to build C6H4 brackets OH2 plus H2O2, hydrogen peroxide, goes to C6H4O2 plus 2 H2Os. And the problem is trying to figure out how all the things relate. So, see, the issue that we've got here is that the equation, this equation here, has 2 people in it, which is a nightmare, and on the opposite side. So that becomes really problematic. In the equation, it's absolutely fine, because in fact, it's great because it gives me both. So what we could argue is that we can have I'm going to make a mess of this now. C6H4 brackets. I really don't like doing this, folks. Going to C6H4 O2 and hydrogen. Well, solve all this. No, it's not right. You could reverse the opposite. You could do this as, so this one, C6H4 brackets OH2 is going up to form that and hydrogen gas as a byproduct. Yeah, the hydrogen gas is going to vanish overall. But then, of course, you don't know that. But how would you know which number correlates to which arrow? Exactly, Nikita. This is why I don't like this. So now I'm going to use this one here to create him as a product. Do you now see why? Don't ever do this. Don't ever try and build a Hess cycle from mixed data. It's a proverbial nightmare. Plus 177.4. Yeah, and then what you can do is you then need water as well. You still need this guy. It's an absolute fiasco. What you're then going to have to do is you're then going to have to do another step in the Hess cycle where you reverse that other one. So where you put in C6H4O2 and hydrogen, that cancels out, and I get the exact opposite value, 17.177.4 plus. But I've now reversed it. Now you say, right, hang on a second. Now that I've got that, but then now you have to say, well, I still need to have hydrogen peroxide. So I'm going to make hydrogen peroxide. I'm going to make hydrogen peroxide from, and then you need to have those guys. Like, it's an absolute but would you say it's useful to practice this anyway? Like in AS, sometimes they'd make you fill in a... No, that's my point, Ria. The Hess cycles that you're going to get given are relatively straightforward, and you just literally add the labels. It's easy. But when trying to do it, if I'm not too confused, I wouldn't even recommend doing it, Ria, because they're not going to give... If you get a complicated question like this, you're not going to use a Hess cycle. You're only going to get lost in it. I feel like I don't want to let this go either, because I feel like if I let... you realize this is a proverbial nightmare. Can I just show you how easy this is now to do with equations? Because it's ridiculously easy when you do it from an equation standpoint. Because the first thing to realize is that first equation gives me both him and him. That's awesome. C6H4OH2, yeah, goes to, and I'm even going to put them where they want. Look how easy it is now when I do it from the equation standpoint. That now is plus 177.4. Right, I can tick him off, I can tick him off. Now I need hydrogen peroxide. There's only one equation with hydrogen peroxide, and it's on the wrong side. This is a product, this is a reactant. Flip it over. So I'm now going to do H2O2 goes to hydrogen gas and oxygen gas. And that's actually balanced already, which is quite nice. And I only need one of them as well, which is awesome. So that one's going to be the exact reverse. So plus 191.2. That ticks off him and him. I still need water. And I've got loads of hydrogen and oxygen to get rid of. Right, so I need two waters. But the water in this equation is a liquid. So I need the liquid equation, which is there. That's a trap, isn't it? True. This is proverbial. No, that's the point. The equations are awesome. Now I need two liquid waters. So I'm going to go two H2O gases going to H2O liquids. And I'm going to double it because I need two of them. So that's going, it's on the same side as what I want. So I just take that number, minus 43.8, and times it by 2. There we go. And then I go, I need another equation, because that now gives me my liquid water. Yeah, but now I need to get rid of the gaseous water and the hydrogen and oxygen, which I've got left over. And of course, I'm going to get that from the next equation. So the next equation, I need gaseous water on this side, two of them. And I also need gaseous water. I need two hydrogens on that side and one oxygen. And what you realize, it's that equation there times by 2, which is easy. And it's even going in the right direction. So I just leave the sign as it is. I just need to be able to multiply it by 2. 241.8 times by 2. Right, and now all I now do is add all of these together in one big long string. So plus bracket, plus 177.4, close brackets, plus brackets, plus 191.2, close brackets, plus brackets, minus 43.8 times by 2, close brackets, plus brackets, minus 241.8 times by 2. And you just run that straight through your calculator and it'll spit out the correct answer. Hess cycles are an absolute mare. Can't stand the things. And this does need practicing. I'm typing in exactly as it is. Plus brackets minus 43.8 times by 2 close brackets plus brackets minus 241.8 times by 2. Go. And I get an answer, a final answer of minus 202.6. Let's check my answer. 202.6 for question number 2. Come on, 202.6. Come on. 202.6. Nailed it. Nailed it. Smash that one out of the bag. Why would you bother doing anything else? It's crazy. You have to use the Hess cycles when they force you into Hess cycles. And they do that on a regular basis. But you've got to be able to run this method. It is by far less problematic than getting lost in a Hess cycle. You have no idea how it all links together. Proverbial nightmare. Right. So what I'm going to do is I'm going to end today's lesson at this point. I'm going to bring my camera back to my forward camera. Front yellow. And what I'm going to do is I'm literally going to say, guys, I need you now to get back on board in remembering how much of a nightmare this topic was. And I need you to be using my support sheet. The support sheet is always there. You've got a mock coming up anyway, and it's gonna have it on it. So please, 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 do some revision on Hess cycles. Do some revision on energetics in general. And I will, and then when you've got some questions, give me a shout. But the support sheet is there. Do as many, remember, do the questions one at a time. Do the question, mark it straight away. Make any adaptations you need. Yeah, and then if you've got any questions, give me a shout. You know that. Next lesson, we're starting Born-Habers, and that's gonna be tough. So do as much as you can. The YouTube videos are there, by the way, guys. Oh, I'm terrible without my glasses. Ugh. The YouTube videos are there. You'll have to kind of swim around. I need to organize them a bit better. But please, please give me a message if you get any stuck on it. But do practice some energetics. You're gonna need it. Guys, I'll leave you be at this point. Go and have a nice rest of your day, and I'll see you soon. See you later, guys. Good to see you again. See you on Wednesday.